Good morning students, welcome to the video lecturing on Sc II SEM Mathematics on Jacobins. Today let us study on the problems on properties of Jacobins. So in the last video we have seen the properties of Jacobins. We have seen two properties. First one is the composite function property. This you have studied already. If u and v are functions of two variables r and s, and r and s are functions of x and y, then the Jacobian of u and v with respect to x and y is equals to dou of uv divided by dou of rs into dou of rs divided by dou of xy. This is called as composite function property. And second one is inverse property. So here if u and v are functions of x and y, and j is the Jacobian, and it is equals to dou of u comma v divided by dou of x comma y, then its inverse is denoted by j dash, and it is equals to this dou of x comma y divided by dou of u comma v, that is the Jacobian of x comma y divided by u comma v, that is the reverse of j. So and we have here, this implies j into j bar is equals to j into j dash is equals to 1. Let us take one example on this first property, that is the composite function property. If u is equals to x square minus 2y square, v is equals to 2x square minus y square, where x equals to r cos theta and y equals to r sin theta, then find dou of u comma v divided by dou of r comma theta. So here first you have to write u and v as it is, and x and y also. So here what we have, what is given, u and v are given in terms of x and y, that is u and v are functions of x, y, and x and y are again, they are in terms of r and theta. So this implies here u and v are composite function of r and theta. Let us use the first property, that is composite function property. So here it is asked to find dou of u comma v divided by dou of r comma theta. So and it is equals to, we know here u and v are not in terms of r and theta. So first you have to find the Jacobian of u and v with respect to x and y, that is dou of u comma v divided by dou of x comma y, into again x and y are in terms of r and theta, into dou of x comma y divided by dou of r comma theta. And from the definition of Jacobians, we have here, this is dou of u comma v divided by dou of x comma y is equals to determinant of dou u by dou x, dou u by dou y, and the second row is dou v by dou x, dou v by dou y, into this dou of x comma y divided by dou of r comma theta is equals to, first with respect to r, that is dou x by dou r into dou x by dou theta, and second row is dou y by dou r in comma dou y by dou theta. So let us substitute the values here, dou u by dou x. Since u is given, u is x square minus 2y square, dou u by dou x is 2x, and dou u by dou y is minus 4y, and dou v by dou x is 4x, and dou u by dou y is minus 2y. You have to write here. And similarly second determinant dou x by dou r, and dou x by dou r is, here r is variable, cos theta is constant, so it is simply cos theta, and dou x by dou theta, so you have to differentiate this with respect to theta, r is constant, as it is root of cos theta is minus sin theta, so it is minus r sin theta. Similarly dou y by dou r is again sin theta, and dou y by dou theta is r cos theta. Let us expand these determinants, cross multiply here, this is minus 4xy, and multiplying these two will get here plus 4 into 4 16xy, and here it is cross multiplying, you will get r cos square theta plus minus into minus plus again r sin square theta. So this is simplifying this, you will get here 12xy into, in these two let us take r common, cos square theta plus sin square theta. So this is 12, substitute the values of x and y. X is r cos theta, y is r sin theta, into this r, and we know cos square plus sin square is 1. So it is equals to 12, r into r is, r into r into r we have 3 times, so it is r cube cos theta into sin theta. So we can simplify this. Here we know 2 sin theta into cos theta is sin 2 theta. So for that Let us take this 12 as 6 into 2. So 6 r cube and into 2 sin theta into cos theta. So it is equals to 6 r cube. We know this 2 sin theta into cos theta is sin 2 theta. So therefore here what we have? We have this is dou of u comma v divided by dou of r comma theta is equals to 6 r cube into sin 2 theta. Let us take one more example. If x equals to r cos theta and y is equals to r sin theta, then find this associated inverse Jacobian, that is j dash, and also prove that here j into j dash is equals to 1. So here this example comes on this second property, that is here x and y are in terms of r and theta, and it is asked to find here this is Jacobian of this one is j of x comma y divided by r comma theta. So its inverse, for inverse Jacobian we need r theta in terms of xy. So that is j dash is equals to dou of r theta divided by dou of x comma y, and it is equals to, we know here determinant of dou x, dou r by dou x, dou r by dou y, and dou theta by dou x, dou theta by dou y. Take this one as equation number 1. So here x and y are given. First you write the given data. X is r cos theta, y is r sin theta. So in case of j dash, we want what here? We want dou r by dou x, dou r by dou y, and dou theta in terms of x and y. So for this, first you have to find the value of r and theta in terms of x and y. After that we can differentiate this. So it is given here x and y. Let us squaring and adding these two. You will get here x square plus y square is equals to r square cos square theta plus r square sin square theta. Let us take r square common in this. You will get cos square plus sin square. It is equals to r square into 1. So this implies here r square is equals to x square plus y square, or we can take this one as here r is equals to under root of x square plus y square. So and dividing these two equations, y by x, you will get here r sin theta divided by r cos theta. This implies tan theta is equals to y by x, or theta is equals to tan inverse y by x. So let us come to this equation number 1. So in this we have here j dash is equals to dou of x comma y divided by dou of r comma theta. It is equals to dou x by dou r, dou x by dou theta, and second row is dou y by dou r and dou y by dou theta. Let us substitute the values here.